Okay, so for the next exam, I only put few questions in there. There isn't much in this particular lecture or new material to put on. So let's go ahead and take a look at some of the review questions. So this way, that will give you an idea to solve the problems. Okay, I'm gonna read a little bit. It says, a recent telephone poll of 996 randomly selected adults. So in this particular problem, we're looking at 996 adults. It says, revealed that 5 in 10 adults believe there has been progress in finding a cure for cancer. So we have 5 in 10 believe cure for cancer very soon. In at least 33 years. In 33 years. Okay. It says describe the population sample, population parameters, and sample statistics. So in this particular problem, they're not asking me to solve for much of the things. All they're asking me to do is to describe things that is need to talk about. For example, it says we need to identify the population in this case. We're given choices to what the population might be. Well, basically, in general, the population is what are we studying? Who is our population that we're choosing from in order to make a decision on whatever it is we're studying. In this case, notice that the sample picked was 996 adults. So really, in here will be the population, or my population has to be the adults in whatever population I'm talking about. Does that make sense?
Yes.
Because normally,
Yes, sir.
if my sample would be, let's say, 50 children, then really my population would be the children's, because I picked from the children. Okay. In this case, we picked from the adults, so therefore the population has to be all the adults in the country because we specify in a particular country. It says, identify the sample for the given problem. Okay, here it is. It says a recent telephone polls of 996 randomly selected adult revealed whatever. So in this case, my sample would be whatever I picked. So in this case, we picked what? 996 adults. So this particular one is simply my sample for this particular problem. Now notice in all of this, there is a select answer, and I'm giving you the conclusion. For example, on this one, you're given choices. It says identify the sample for the given problem. First choice was A. It says all adult in the country. Really, somebody has the mic on. You can turn it off if you want. If we're looking at all adults, that's not going to be a sample. That's really the population. So the second, another selection, it says 5 out of 10 adults in the country. This is a statistic, so it's not really a sample. Again, 5 out of 10 of the 996 adults selected. Again, this is not a sample. This is considered both things, statistic and samples combined together. So in this case, the sample would be whatever portion I picked from the population that I'm looking for. It says identify the parameter in the given study. Choose the correct answer. The parameter in this case are the percentage of adults in the country who believe there has been a progress, because we're looking at two things. Either they have been progress or they haven't been progress, right? And in the final, it says 5 out of 10 adults believe there has been progress in finding a cure for the cancer. So in this case, this is the statement that describe my sample, my parameter, okay? And the last thing is identify the sample statistic. Again, we go back to the statistic. There should be a number that we pulled out from the study, and our study indicate what? 5 in 10 or 5 out of 10. So this is basically the statistic for this particular study. Okay, so that was problem number 1. In the test, if you have this problem, it would be something similar to that. Okay, so again, you do have 2 choices, 2 opportunities to take the test. If you don't do good on the first time, you might want to do it, repeat it again, so you can do better. Any question on question number 1? Determining, all of these are really definitions in your book, so you can go ahead and pull them out if you want to, and that will be helpful as well. Any questions?
No question.
No questions. Another type of question, it says, to determine her mood, Denise divides up her day into 3 parts: morning, afternoon, and evening. And then she measures her mood at 3 randomly selected times during each part of the day. What type of sampling is used? Now, this is a problem. The more or less is a definition. In this particular case, since we're talking about interval, and interval is really stratified sampling. So for this particular problem, we have a stratified sample. Okay, any questions?
Okay, can you repeat that last part? I heard that she determines her mood by dividing the day up into 3 parts, but then the last part.
Okay, it says to determine her mood, Denise divides up her day into 3 parts. So she divided her day into morning, afternoon, and evening. She then measured her mood at 3 randomly selected times during each part of the day. So during every part, she should go ahead and she measures her mood, whatever. It says what type of sampling is used. Anytime we have a sampling that talks about particular interval, then we call that a stratified sampling.
Okay, thank you so much.
She's specifying a particular interval during the day. On problem 3, it says use 6-point bins, and they're giving you example. Now you have and it says 94 to 99. And again, another example, or 88 to say 93. Okay. It says use 6-point bins. 6-point bins means we have 6 points in every range of numbers that we're going to take. So another thing, you have 94, so we have 94, 95, 96, 97, 98, 99. So notice there are 6 points in that particular range, yes? So if it says 7-point bins, then we're looking at 7 points and so on. Clear? All right, it says to make a frequency table for the set of exam scores shown below, include the column for relative frequency and cumulative frequency. Well, this is a nice problem. We're going to go ahead and do that. I know you don't have the problem. I'm going to try to write the problem down and the numbers down so we can go ahead and look at how we do that. Okay, so we have the numbers, scores are 66, 77, 92, 70, 86, and then 69, 74, 80, 94, 72, 81, 94, 65, 96, 72, 87, 68, 77, 84, and then 90. Okay, these are the scores given. Okay, so these basically the scores given in that particular problem, and it says use 6-point bins 94 to 99, and then we're going to go ahead and see how far we have in all of these. Now, I'm going to start with, say, 94 to 99. And then below that, the next number over here is going to be 93. And I'm going to go 6 numbers down. There's going to be 88. Now, you remember, you're going to add this number and that number. And then we have 87, 82. And then we have 81, and then we have 76, and then we have 75, 70, we have 69 to 64. So these are the bins given. You can call these bins, classes, whatever, whatever names they call. Then we're going to go for, first one is the frequency. The frequency tells me how many students got a score between 94 and 99 on the exam among these scores. So let's go ahead and figure that out. So from 94 to 99, nothing yet. 1, 2, 3. I got 3. What you got, guys? So let's see. 1, 2, and 3. Let's see what's the next one. So I don't have to do all of them. Again, from 88 to 93, let's do that one more time. So we're looking at 88 to 93. So this is in there, 1. And 90. So according to this, we have 2. So I'm going to write 2. And so on. So 82 and 87, there are 3. And then we have 4. And then we have 4. And then we have 4. So the total number is 4, 12, 8, 12, 15, 20. And if you count all of these numbers up there, you should have 20 of them as well. Okay? So this is the first table line of the first column of the table. The second column says relative frequency. So to figure out the relative frequency, you really do is the following. You take the frequency and you divide it by the total number. In this case, we have a total number of 20. So in this case would be relative frequency would be 3 divided by 20. Or you can write it in decimal and let's see, did this in this particular problem, it didn't, it just asked to write the frequency below. So 3 out of 20 is going to be about 15%. Now notice, if they give you a percentage, you do have to write it in a percent fashion. How do I find the percent fashion? You multiply 3 by 100 and divide by 20. So 3 divided times 100 is 300. 300 divided by 20, that would be 15. Okay. So the second one in this particular frequency, so this is 10%. Again, it will be 200 divided by 20. Remember, take the 2, multiply it by 100. That gives you 200 divided by 20. It's 10%. The 3 is also, again, one more time, 15%. The 4 is simply what? 20%. The 4 is 20%. And then 20%. A total of 100%. So you should have 100% in total quality. So 20, 40, 60, 75, and 25 for both of these would be 100%. And the next one is called the cumulative frequency. The first one is what you have here. So that's the 3. The second one is the sum of all the above. So 3 and 2 is 5. On the third one is everything 3 and everything above it over there. So that's going to be 3, 4, 5, 8. And then the fourth one, it would be everything here plus the 4. So that's 8 and 4 is 12. And then 12 and 4 for the next one will be 16. And 16 of 4 is 20. Now notice your last one should be exactly how many tests you have. Okay. So this is basically a little explanation on all of this. Is there any questions? Is that okay?
Clear. Thank you.
All right. So let's move on. It says, use a frequency table. So it says we're trying to create a histogram. I need to know which one a histogram. Let's use this frequency table over here. So really, I don't need all of these anymore. Okay. I only need the frequency. So I'm just going to go ahead and use the frequency for those. So how do I graph the frequency? Now, the first line, that would be your frequency. Let me write it. And then your horizontal line, in this case, this is going to be your scores. Okay. In this particular case, we have a score from 94 to 99. And let me start with the smallest one, with 64 to 69. So let's say this is your 64, this is your 69. And then we have a score is going to go up, and the frequency is what? 4. So 1, 2, 3, 4. That would be nice to do that. However, when we're talking about histogram, Histograph. Histogram actually. We notice that these bars going up has to be connected. However, you notice the first one ends at 69, the second one starts at 70. So if I wanted to start the next one, I'm gonna start with one a little bit more, which is 70. So in this case, we should, according to the histogram, they have to be connected. Then what we do is we split that difference here between them. We give half to this side and half to that side. So instead of going up to 69, I'm just gonna go up to 69.5, and really between 69.5 and 70, there is nothing. So I'm not doing anything extra. So the second one starts at 69.5 and ends at 75.5. And for this one, we also have 4. So we're gonna go up to 4. And then the next one would be, we're going from 75.5 to 81.5. So 81.5 again. This one is 4. And then we have a 3. So I'm just gonna go, the next one is gonna be just up to here, just 3. And then one more, which is 2. So the next one is 2. And then the last one is 3. So this line over here represents the frequency. This line over here represents the scores. And since we're talking about the scores in there, so these are my scores. Sometimes we, in order not to confuse this issue, we take the middle number here, another way, and we give it one name. So 64 and 69 halfway is 66.5. So we'll pick a point over here and say 66.5, and this one would be halfway, and so on and so on. But these are the same representation, no matter which way they represent it, it really doesn't matter. Any questions? We're clear on those?
So it could be either way on the test, right?
Right, on the test, they could ask you to go ahead, and they can give you the middle number, or it will just give you those. They will give you just another way. You'll be looking at a graph. Actually,
Okay.
this is what the tests look like. So this is your question. You're gonna select the correct graph out of this. You're not really actually graphing it. All you do is, I don't know, can you all see the graph?
Yep.
Yeah, I can see, sir.
Okay, let's say we know 20 to 21 is 0. So this is your 20 to 29. On the first one, you can see there is no 0 there, right? However, this has a 0, this has a 0, this has a 0. So I deleted that from the questions. 30 to 39 is 11. Over here, it looks like there are 5 each dot. So 5, 10, 11, that looks fine. That looks fine. That looks fine. So on the second is 15. This doesn't look good. This doesn't look, they all look good, they're 15. And then it's 6. So this number has to be, hold on a second, 30, 39, I'm sorry. This is not good because 11 is not there. It has to be up there. So so anyway, just look at the numbers and match it in there and see which one you're gonna take out as you go, okay? So you start eliminating one by one, and whichever one that belong to this table, therefore this would be your correct answer. Does that make sense?
Yes, sir. They actually had multiple questions like this on the homework through
On the review?
Yeah, on the Module 8 homework through Pearson, there's a couple questions like this already.
Okay. And this one, again, I'm not gonna be able to do it on the board because it's too much. Let me put it on the screen a little bit. Now it says you're given the following religion and then percentage, right? And in here, it's supposed to be colored one. So I'm not worried about the color right now. I'm gonna show you what to do with that one. Notice the box over here supposed to have exactly the same percentage. Anyone that doesn't have the same percentage, you can take it out. So for example, Protestant says here 26.9, but it's supposed to be what, 37.9? So these ones are no good. This one is no good either. So my answer has to be either B or C. And then we will continue looking at the rest of it. Now the Jewish is 2.7. Here it says 2.8, so I eliminate that. My answer is that. So basically, some of those questions are based on a graph. So we'll go ahead and do that. But let me show you quickly how you do the percentage on the graph. You're not asked to graph it, but just in case it came up somewhere else, you can go ahead and do that. So let's go ahead and pick something. Let's say group A is, let's say, 40%. Group B is 10%. Group C is 15%. And then group D is, so that's 40, 50, 65, say 35%. How do I represent those on a pie graph? To figure out on a pie graph, actually we're going to start on the center. You can pick any line to start with. Let's say I want to start with this line. So first of all, 40%, I need to know what angle is that. We know the whole angle around is 360 degrees. So we have 40%. So all of these are 100%. So 40% times that, that's going to be 90. Yeah, let's see. 0.4 times 360. And you figure out that number, and that will give you a, let's see, that'll give you a whatever number in degree over here. So let's say 4 times 6 is 24. 4 times 3 is 12. Plus 2 is 4. So we have one number, and we have a 0. So that's normally 144 degrees. So I'm just going to go over here and measure 144 degrees. This is your. Does that make sense? Yes?
Yes.
Okay, to figure out what 10% is, 10% of 360 is 36. So now I'm here, I'm gonna measure from here to say this point over here, say 36. And that's gonna be B. And D is 15%. If I take 15% multiplied by 360, that should give me about 36, 40 some. So I'm just gonna make it 40, about that much. And whatever this number is, that's gonna be C. Okay? So I'll be, actually this would be 48 or 52. I need to make up my mind. Anyway, the last one would be 35%. 35% is a little bit less than 44, 144, and that would be part D. Yes? So you're just doing measurement for the angle on that one. So this is same thing over here, but they're not asking you to measure it really, to go ahead and graph it. All they're asking you to do is to choose which one of those graphs would be the most appropriate for the given problem. Okay? Another type of graphs say we have a graph. Let's see if I can do something with that. Let's say we have something like that. And let's say we have this. And let's say this is the blue region. And let's say we have another graph. And this is your pink region. And let's say we have red region. Now, and each region is basically represent some kind of degree, okay? For example, we could say the red region is sometime from say, let's say 92 degree to 100. Then we have 100 degree. The blue is a little bit, oops, we need to put it in a process where it's color coded. So let's call this region, it has to be hotter than red. So whatever it is, you want to call it, this is 110. Let's say we have a blue region over here, and the blue region is a little bit cooler. And say this is 75. Now the question about this particular graph, which say, all right, what color from what temperature to what temperature would be the red region? So we already know we're gonna take the two lines that cover the red region. So in this case, these two lines, and determine what temperature they have. In this case, this is 90, this is 100. So the red region would be between 90 and 100 degrees. Okay? Or it could say, it says, what can you say about the temperature in the blue region? Well, we know the temperature in the blue region has to be somewhere between 75 and 90 degrees. So those are particular what you see on the news every day. They have a particular graphs, and then they just go ahead and put colors for you for the temperatures. Okay? Any questions?
Here, thank you, sir.
All right. And let's take a look at another graph. Okay, let's see what we have. We have the particular graph. And here we have the mean score. And then on this one, we have country. And in every country, two people took they were scored. We start in that. Let me put some numbers over here. Let's say we have 460. And then we have 480. and say we have 500, 520, 540, 560, and 580. And here we have country A, country B, country C, country D, country E, and maybe country F. And just extend that F. Okay. Now, in each country, two different teams will play. So we have the boys and the girls. And let's say red is for the girls, and say black is for boys. Okay? And let's say the score for boys, country A went up to a little bit above 500. And then for girls, it was, say, 500. Let's go to, say, country F. I'm just gonna put another couple of numbers, or country E. Let's say we'll go for E. So those are the scores. Of course, B would have some score, C would have some score, D would have some score, and F would have some scores. It says, consider the data displayed in the table. It says, which group scored higher on the test? Boys in country, say, A, or girls in country F, or in country E in this case. So we're looking at two particular scores. Boys in A, now we know the boys are the black, so we're looking at this one. And then the girls in E, the girls is red, we're looking at that one. So the boys scored about 505. And here the girls scored about, say, 530. Based on that given, so we can say the girls in country E scored more than boys in country A, and their score was 530 versus 505. Any question on that?
Clear. Thank you.
All right. Let's go to another type of percentages. For this particular one, we have two players who are playing baseball. Okay, player one. So player one has, and we have player two. This is first half, second half. Okay. So number of hits was 50 and versus 10. At bats, we have 150 versus 50. Now, the batting average for each one in this case, for player one, a batting average is simply how much? 50 divided by 150 is 1/3. And here it's going to be 1/5. Or you can say this is 0.33 and this is 0.2. So this is basically the average, the batting average for each one in the first half. In the second half, so we have hits. Player one had 35, and then at bats we have, say, 70, and then we also have 70 to 150. For average, we have 1.5, 1.467. So another way, in the second half, we have this guy hit half the balls, this half hit 0.467% of the balls. So the question is, whose average was better in the first half? So in the first half, player one had an average of 0.33. Player two had an average of 0.2. So we assume, in this case, first half, player one had a better average. In the second half, you can also see that player one has 50% average. Player two had 46% average. So in the second half, again, player one is average. However, who has a better average for the whole season? Let's see. So the first one for the whole season, he played 150 and 70 would be what? 220. So we have, this is player one, total at bats is 220. Total hits would equal to, now he got 50 and 35, that's going to be 85, so it's going to be 85 divided by 220. For player two, we have 50 and 150, that's 200 total at bat. And then total hits is equal to 10 and 70, which is 80. So, all right, let's go ahead and do that over here. That was 85. And average is 85 over 220. Over here, average is 80 over 200. So if we take each one, 80 over 200, that is going to be about 40%. And really 40% of that is going to be what? 86, which is less than 85. Let's see what average we have. So this one that gave me about 38%. This one gives me 40%. Notice, even though player one was better in the first half, he was better in the second half, but in total, he wasn't better. He was worse. That's what we call deceiving numbers, right? Any questions?
Makes sense.
Does it make sense? I hope. All right. So with that, let's move on to our next one. On the next problem, we're given it says the table to the right is based on assumption that 1% of breast tumors are malignant. It also assumes that mammogram screening is 85% accurate. Complete part A to C. So here's what we have. We have tumor is malignant. And let's say this is your total over here. 1, 2, and total. And like that. Okay, here's what we have. Positive. So we have positive, negative. There's 85 positive, 13, 84. And then 14, 69. Also have 15, 85, 16, 85, 31. And total is 100, 900, and 10,000. Okay, so this is basically a table of what's given on this particular problem. It says, suppose a patient has a positive mammograms. What is the chances that she really has cancer? So if they have a positive mammogram, we are on this category. So these are positive, this is the total. Out of all the positive, the ones that really have cancers are these ones, yes? So the percentage, if you are positive, the percentage that you have cancer would be 85 divided by 1469. It will be 85 divided by 1469 times 100. And that should give me about 5.8%. So there is a 5.8% chance that you will have cancer if you test it positive. Any question on that one?
No, sir.
All right. It says, what is the chances of a positive mammograms given that the patient has cancer? Now, I didn't write the problem out, but I did say it also assumes that mammogram screening is 85% accurate. So if they are diagnosed you to have cancer, so that means you have 85% of the chance, 85% possibility you have cancer. Why? Because the test is 85% accurate. Does that make sense?
Yes, sir.
So if I test you with that test, which is 85% accurate, then I would say, well, 85% chance that you may have cancer. It says, suppose a patient has a negative mammograms. What is the chances that she actually has she actually does have cancer. So for the people who test negative, here's the negative testing right there. 15 actually will have cancer out of 85/31. So the percentage would be 15 divided by 85/31 times 100, just to put that in percentage manner, and that should give me 0.18%. So there is less than 0.5% that if you test negative to have a cancer. Any question on those?
That one right there, sir, can you move a little bit to the left? I can't see them. You said 15 divided by,
Because we have 15 who would test negative that actually have cancer.
okay,
And the total number that will test negative is what? 8531.
okay, so divided by 8531%.
And that should, I multiply that by 100 to figure out the percentage.
Got it. Thank you. Got it.
Okay, in another problem, we're given the following. It's simple, it's supposed to be the same, but we have the following. Let's say 93 true, positive, 1475 false, positive. Yes? And we also have 13 false, negative. And then we have 8395 true, negative. We have a total of 106, 9870, 9976, 8408, 1568. Now here it's similar to the previous one we had, but in here they clarified a little bit more on those numbers. For example, when a person tests positive, we assume he would have a cancer. If 93 of them have a cancer and they tested positive, so this is we call true positive because they actually had the cancer. 1475, even though they tested positive, they didn't have it, so therefore this is false positive. In the second one, those people who tested negative, 13, those 13 tested negative, yet they do have the cancer, that their test was not true. So it is false negative. And 8395 did test negative and they didn't have the cancer, so those are true negative. Now the question is, it says, use the table. What was the total number of women whose test gave incorrect results? So how many women we have that got incorrect results? What do I do in this case? Is this a true result? Anybody? Looking at the first one, is this a true result?
Yes.
How
No.
about this one?
No.
No. So this is, we got 1475 so far. How about this one?
This one false. So it's not.
So now we have 1475 plus 13. This one is also true. So this is false, this is false. So how many people got a false result? 1475 plus 13, that will be 1488. So this problem was just simple and easy, like the other ones. Any questions?
No.
Well, actually, basically, this is everything there is in these two sections remaining that you're supposed to do for the final exam. And I believe that's it for the questions. That should cover all the questions on your test. And hopefully we're done with that. Any questions on that? No?
No, sir. Sounds good. I think we'll
All
take
right.
this.
So this is basically what your test is gonna be like. I'm just gonna go ahead and put I'm gonna save this session and I'm gonna put it on online like the other ones. I've noticed some of you already pulled out the other one without me giving you where it is, but I guess you already know where it is, yeah.